Hello, today we're going to learn how to add and subtract fractions with unlike denominators. In this problem here we have 2/3 plus 1/9. Notice here this picture is a model of 2/3 and this picture is a model of 1/9. Except the original 2/3 I broke down into 9 equal pieces. Now I had 3 equal pieces that then I continued to break down into 9 equal pieces, which now is showing me that I had 2/3 originally, which happens to be equivalent to the fraction 6/9. Now I know that because I can simply count how many pieces I have here. 1/9, 2/9, 3/9, 4/9, 5/9, 6/9. But originally I had 2/3, however 2/3 is equivalent to 6/9. So now I can substitute 2/3 for 6/9 in this problem. So now I have 6/9 plus 1/9. And notice that my denominators are exactly the same now, showing that the size of each of these fractions are all from ninths. That's our goal. We need each piece to be an equal size. Notice this is a ninth, this is a ninth. Everything is ninths that we're adding together. And now that everything has the same denominator, I can simply add my numerators. 6 plus 1 is 7. And my denominator stays the same as 7/9. Now, I do enjoy drawing models to help me solve this problem. Some of you might be able to quickly identify the least common denominator and then simply add your fractions. Either way works. Now, in this problem here, we have 2/3 plus 2/4. My first goal is to figure out, is my denominator the same or different? I have a denominator of 3 here and a denominator of 4 here. My goal is to find the least common denominator first because that will help me to find an equivalent fraction for both of these. So now I have the denominators 3 and I have the denominator 4. Some of you might right away recognize the least common denominator, but if you are struggling to find it, I recommend writing out the multiples of each of your denominator. We have 3, 6, 9, 12, 15, 18, and I'll stop there. Here we have 4, 8, 12, 16, 20. Now, when I'm looking down here at this column, I notice that I have a 12 in this column, and I also have a 12 in this column. That is going to be known as now my least common denominator, and that's the denominator we're going to use for this problem. Now, some of you might have continued counting your multiples and listing them out, and you might have recognized that 24 is also a common multiple for 3 and 4. Using 24 is not incorrect. That's completely correct. However, choosing a smaller denominator will mean that there'll be a little less work on your end when you're solving these problems. So now I'm going to make 12 my denominators. And my goal here is to determine if I had 2/3, what 3 times what number gets me to 12? Well, I know 3 times 4 is 12. So if I multiply my denominator by 4, I need to do that to my numerator as well. So 2 times 4 is 8. 3 times 4 is 12, proving that 2/3 is equivalent to 8/12. Now I have 2/4. 4 times what number gets me to 12? 4 times 3. So if I multiply my denominator by 3, I do the same thing to my numerator. So 4 times 3 is 12, 2 times 3 is 6. And that proved here that 2/4 is equivalent to 6/12. Now my denominators are exactly the same, which they are 12. So all I need to do is add my numerators. 8 plus 6, we're left with 14/12. And you can leave your answer as an improper fraction, and you do not always need to simplify it. That is absolutely fine. Now in this problem here, we have 5/8 minus 2/5. Now what we just did with adding, finding the least common denominator, you're going to do the same exact thing for subtraction as well. So again, some of you might recognize the least common denominator, but I recommend listing out the multiples of 8 and 5 because they are my denominators. So I have 8, 16, 24, 32, 40, and 48. I'll stop there. Now I have 5, 10, 15, 20, 25. Now notice I'm not stopping because I haven't found a number that's also in this column. 25, 30, 35, and 40. So I'm going to stop here. And of course, if you continue on, you'll still find other common multiples, but we want the least common multiple here. So we have 40 and 40 in both columns. So that's going to become my denominators. But now I need to figure out what fraction is going to be equivalent to 5/8 that has a denominator of 40. So 8 times 5 is 40. So if I multiply my denominator by 5, I do the same to my numerator. So now 5 times 5 is 25, and 8 times 5 was 40, proving that 5/8 is equivalent to 25/40. Now I'm going to do the same thing here. 5 times 8 is 40, and 2 times 8 is 40. And 2 times 8 is 16, excuse me. So now we have 16/40 here. Notice we did 2 times 8 is 16, 5 times 8 is 40, proving that 2/5 is equivalent to 16/40. Now I check my denominators, they are the same, which is excellent because that means I'm ready to subtract my numerators. 25 minus 16 is 9, and your denominator stays at 40, giving you an answer of 9/40. Notice when you are adding and subtracting fractions, you always need to check the denominators. If they are different, you need to find the least common denominator before you add or subtract your numerators. In this problem here, it's asking us for which of the following sums could 30 be used as a common denominator to make equivalent fractions. Select the 3 correct sums. Now looking at these answers here, I noticed they actually did not add any of these fractions together. All they're doing is identifying which fractions you would choose to make 30 your least common denominator before adding them. So here, I'm just going to underline 30 so I don't forget that's the denominator I'm looking for. So if I have 1/3 and 4/15, I'm going to start by listing out my multiples. I have 3 and I have 15. So 15, 30, 45, and I'm going to stop there. Here I have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, which is excellent. So even though I noticed I saw 15 and 15, 15 could be used as my least common denominator for this problem, but you could also use 30. And this problem is asking us for which of the following sums could 30 be used as a common denominator. So yes, it's easier to choose the smaller common denominator, but for the purpose of this problem, they want to know, could you potentially use 30 as the common denominator? And this proves, since 30 is a multiple of 3 and 15, yes, you can use 30 as a common denominator. Now notice, even though I chose the larger common denominator, I'm not actually solving this problem. So it's okay to identify 30 and 15 as potential common denominators, and this problem didn't even ask me to solve. Now I have 4/9 plus 1/15. Well, I know 30 is a multiple of 15. However, is 9? Let's see. 9, 18, 27, 36, so there's no way I see 30 in this column, so 30 cannot be used here as a common denominator. Here we have 18 and 30. Well, 18 times 2 is definitely not 30, so we can't use that either. Now we have 6 and 30. Well, 30, yes, that's great. That is our denominator, but let's see if we can use if 30 works for 6 as well. Well, I know 6, 12, 18, 24, and 30, which is excellent. So 6 times 5, in fact, is 30. So this is proving that I can use this as well. Now I have 8 15ths plus 3 20ths. Well, 20 times 2 is 40. So there's no way we can use 30 for here, even though 15 times 2 is 30, but it doesn't work for 20ths. Now I have 2 fifths plus 5 sixths. Now I do know that 5 times 6 is 30. And I do know that 6 times 5 is 30 and 5 times 6 is 30. So that's proving that 30 can be used as a common denominator here as well. Notice I found my 3 correct sums. Now, even though I had to look through each problem to determine can I use 30 as a common denominator, it was never asking me to actually solve the problem. So as you work on today's activities, make sure you are fully reading the directions. At times, it might ask you just to determine the common denominator or the least common denominator. It might not actually ask you to add or subtract. So if they're just looking for the common denominator, just type in the common denominator as your answer. Many times, finding that least common denominator is the hardest part of the problem. So if you're able to do that, you can definitely add or subtract. So as you complete today's activities, you are welcome to refer back to this video at any time.